Hello. Hello. Okay, so we'll solve two more graph problems from CSES, and which is first one is message route. So I think yesterday we discussed the basic. No, this problem is very similar to the first one actually. So instead of grid now we are having edges and nodes. Okay, this problem is similar to this labyrinth or counting labyrinth problem. Second problem. So the logic is very simple. We are given like n nodes and we have m edges. Okay, we'll start the BFS from 1. Okay, and if we reach n at any point we will break. Okay, break or we will terminate the BFS. And while we are doing this BFS, we will also keep track of parent of each node. Okay, so that it is easier for us to build the answer after the BFS. So this is the simple logic, and given the constraints, yeah, it will work. Since BFS will take like n plus m, right? BFS will only take n plus m. What was the time complexity of BFS? See, n plus m. So yeah, let's just implement this. We need this. We need this. BFS. We need BFS. We don't need DFS. Okay. Copy the input, paste it in the input file, and okay, every connection is between two different computers, so there is no cycles, and there is at most one connection between any two computers. At most one. What does it mean? So either there is no connection or there is. So no, not like you have 1 to 2 and then again 1 to 2. I think that is just redundant. It doesn't matter. So we have the base ready. Okay, and sorry, so we have the base ready, and I just need to do BFS from 1. Okay, and in that BFS only will solve the problem. So we don't need this, we don't need this, we don't need this. We need a queue which will store an int, and also we will need a parent array. So yes, and initially parent will be -1. Okay, or parent will be 0. We will be given a source, so we will do parent of source is -1, and then we'll start. We'll have a visited array, so with src is true, or with src is true. Okay, and then we'll push, not push src. While queue is not empty, we will take out the current node, queue dot front. Okay, we'll take out the current node. Should we check if it is visited or not? Oh, no, I don't think so. So if this current node is n, so we'll break, and also we will parent of n will already be set, so there is no need. Okay, we need a flag. Initially it is false, now the flag is true. Okay, and we break out from it, and we will iterate in all the neighbors, iterate through all the neighbors of the current node. So current, and check if it is not visited. If it is not visited, then we'll do visited node is equal to true, parent node is equal to your current, and then push it into the queue. Now that is done, we will need answer. Okay, and so we have if flag, otherwise the answer is simply impossible. Flag true means we have reached n from 1, so there is a path. So we'll have an answer, and we'll take an t, which is n, and while t is not equal to -1, we will do answer dot pbt, and t is equal to parent t. Okay, and we will just reverse all answer, and what is the output format? So size, and then your answer itself. So this should work. Okay, with src is true. Okay, so viz is different, I think. Viz is different. Okay, so while loop, no issue in while loop, most probably. Okay, we're not popping in. Q dot pop. If you are not popping it, then the state will, or yes, 145. Okay, so what is this graph? 1213. Can I paste it? Okay, so this graph is basically, we have one is connected to 2, we have 3, we have 4, so one is connected to all these, 2 is connected to 3, and 5 is connected to 4. So there is one option only, 1 for 5. Okay, so this will work. Correct. So now building teams. Building teams. So building teams. N pupils, M friendships. So usual graph input. Your task is to divide the pupils in 2 teams such a way that no 2 pupils in a team are friends. Bipartite type of, no 2 pupils in a team are friends. You can freely choose the size of the teams. Okay. I have to divide in 2 teams. So it is similar to bipartite only. Okay. So it is the bipartite type of. Okay, so let's take this example. I'll put it here. So we have this graph where we have 1 connected to 2, 1 is connected to 3, and 4 is connected to 5. So you see, if we start from 1 and 1 is now in team red, or basically first group, so 2 and 3 cannot be in red group, they have to be in green group. Okay, similarly if 4 is in red, then 5 must be in green. So the answer for this will be 1, 2, 3, 4, 5. So 1 and 4 will be in the same group, and 2, 3 and 5 will be in same group. So yeah, this is bipartite only. So we will run a loop from 1, we will do a DFS. Okay, we will do a DFS, and with each DFS we are just going to assign the, we will assign the XOR of that number of its parent. Basically the Suppose if I'm coloring one with one, okay, so these two will be colored with XOR of 1 and 1, so it is 0, okay. And if these are colored in 0, then their children, or if they have any, they will be colored in XOR of 0 and 1, so basically 1 again. And in like while doing the traversal, is there any possible type? Okay, if we encounter any node which is already colored and the color is not equal to the XOR, or color is same as the parent, then in that case we will return false. Okay, so we need a boolean DFS. We will need a boolean DFS. Okay, so we have the basic idea of how to solve this problem. Okay, and let's go and implement it, then only we will be able to see. Okay. So BFS or DFS? Should we do BFS or DFS? BFS will be easier in breaking out of, so basically we can do both, any of them. We can do any of them. Let's do both. So first we will do from DFS. So now it will be a boolean DFS, and we will have a team. Okay, and we will assign what do you call this? Team and assignment. Assignment. Color. So we will color our current to the given color. We will traverse and see if the node is not visited, and if it is not visited, then and if our DFS node vis color XOR 1 and team is true, then we will return true. Else if else if else if means the node is already visited, or either the node is already visited, or let us do it like this. So if it is not this, I will return this. Now whatever it is, true or false. Otherwise, if it is already visited and the color is and the color assigned to it, team node is double equal to the given color, so we'll return false. After all this, return false. No, return true. Okay. Okay. What is the output? Output is answer. So we need a team array. Size will be n+1. Initially all set to 0. And then what we will do is I will run a loop from 1 to n, and if not visited node, then we will do a DFS from that node along with the details, which are color will be, if it is not visited, then I am starting with color 1 only. The last is team. Okay, and after this I will do this. Flag is equal to this, and if flag, that means and then we have I should give them 0. Impossible. What about this? One one two one one two. Okay, so we don't want this. We want this 1 2 1 1 2. So no, it is wrong answer. It's not correct. 2 and 5 are in same group. 1 and 4 or 1 or 5. Okay, let's try to run this. We start from 1. You start from 1. 1 is not visited. So we will do flag is equal to dfs 1 with 0 color team. Okay. So dfs 1, it is not true, and the color is now 0 for 1. And then for all the adjacent nodes we will do, if the nodes are not visited and the dfs of node with viz and the color set to 0 team, does it return true? If it is, then we'll return true. So we will be able to do it because 1 is connected to 2, and so 2 will be, we will be able to color 2 with this. And when we come back, so the second node will be 3, so for 3 it is also possible. So 1, 2 and 3 are set, but here it is not correct. So it is not going for 3, and it is just returning from here only. Okay, let me do it in another way. So we have this. It's the same. what do we call the bipartite? I don't. I won't do FS. So this. Okay. If not this, and return false. Otherwise, we'll return true. That was the only thing. Damn, bro. 1 double 2 1 2. So 1 and 4 are in the same team, and 2 3 and 4 are in the other team. Okay. With VFS also we can do this. So let's see. Let me remove the unnecessary code. We don't need parent. We do need source. So we'll start from that. Flag also we need. We don't need this. We'll process the so the current color for the current, so we need the team okay. So we will do so we need to store it with two things. Source with colored 0. Okay, and auto. We have current.ff will be set do we need this? Do we need this? Maybe. Okay, so this is equal to current.second, and otherwise if it is not visited we'll do this, else if it is visited and the team node color is similar to the current color, which is second, in that case flag will be set to false and will break it, and out of this if not flag then also we will break it. Return flag. This is a boolean. Visitor node is true, parent node we don't need this, we need color. So team node is, and this is current first is current second. We don't need this. We don't need this. We will send this current.second XOR with 1. Okay, so BFS. Impossible. It is true initially. 12212. Same answer. So it is our choice whether we want to do it with DFS or BFS. I like DFS personally, so I'm going with DFS only. And if we submit the BFS code, which is this, this should also work. Okay, wrong answer. I think we should do it here only. Steam node current.ss and here we will do team srcs 0 122. Okay, wrong answer. This is wrong answer. Why current.ss? Triple 122 1 triple 2 1. Okay, so there was a little mistake on my side, and I think this should work now. Okay, done. Byteland has n cities and n roads. Design a trip, 2 or more cities. Okay, distinct route. So we need a route that contains k distinct cities in a round trip. Okay, I forgot how did I solve this. I don't remember. Round trip. You can see also see my submission here. See. I don't remember how did I solve this. Okay, so we'll leave it for. Oh yes, we solved 3 problems today, but I don't think we'll be able to solve that problem today because time is over. And also, one more announcement is that tomorrow I will not be streaming. The next day after that, and so most probably after Republic Day. So 27th. I will be able to stream again. Okay, so since this like it's a long weekend, right? We have Saturday, Sunday, and Monday off. So I'm planning. I'm not planning. I'm actually going to home. So yeah, that was the only major thing I wanted to convey. And yeah, there's these 3 days I'll try to maybe do some stream, maybe I'm not sure. Okay, so I guess this is it, and we'll meet on Tuesday most probably. Yep. So yeah, till then, take care, and